Welcome, everybody. We are going over section 2.3 today, solving multi-step equations. It is going to be the same exact thing that we've been doing in the previous two sections. We're using those same properties of equality, inverse operations, and the properties of real numbers, but the only difference this time is that there's more than two steps. Okay? So we're going to jump right in. We're going to work on this first problem. So as you can see, there are way more terms than we're used to. So it's asking us to find the solution of 5 equals 5m minus 23 plus 2m. We see that we have two terms over here, the 5m and the 2m, that have that m variable, right? So let me just change my color. So the first step in doing this is I want to move these two terms next to each other, just so it's easier for us to work out. So I'm going to rewrite this as 5 equals 5m. I'm going to move this plus 2m next to the 5m, and then I'm going to write this minus 23. Now, the reason I can rearrange those terms like that is because of this property called the commutative property of of addition. What that says is that if you have terms being added or subtracted together, you can change the order and it doesn't alter the truth of the equation, okay? So now I have these two terms written next to each other and I want to combine like terms. So that's my next step. I'm combining like terms. The way that I do that is I keep my variable the same and I just add the coefficients. So I'm doing 5 plus 2, which is 7m, and then I'm rewriting this minus 23. Now I'm down to a two-step equation, which we did in section 2 too. So what I want to do is get rid of everything except for this m on the right-hand side. The way I'm going to do that is move this 23 first because it's furthest away. I see subtraction, so I want to do the inverse operation, which is addition. I do it on the right, that means I have to do it on the left also. 5 plus 23 is 28, which equals 7m. 7 and m, they are attached through multiplication. So the inverse operation of multiplication is division. And I'm left with m equaling 28 divided by 7, which is 4. Okay? So I'm going to encourage you guys on your own right now to first check this problem in pink, okay? Where m is 4, you're going to plug it back into the original equation. And then what I want you guys to do is try one on your own. That problem is going to be negative 2y plus 5 plus 5y equals 14. Okay? So please pause now, check that pink problem, and do this blue problem, model it the same way as the pink. And we are going to move on. So, next up, we have this next example, okay? So what is the solution of negative 4 times the quantity of 2x minus 1, which equals 36? So I see parentheses, so instantly my head goes to the distributive property. So we have talked about before, this number in front of the parentheses needs to be distributed or multiplied through both of the terms that are inside of the parentheses. So let's rewrite this out with that going on. So I'm going to have negative 4 times 2x minus 4 times negative 1, which equals 36. And then I'm going to simplify. So I have negative 4 times 2x. Negative 4 times 2 is negative 8x. Negative 4 times negative 1. Two negatives give me a positive, and I know that 4 times 1 is 4. And that gives me 36. Okay? Now we have a two-step equation. I want to get this x alone, so I need to move this negative 8 and this 4. The 4 is furthest away, so I'm going to do the inverse operation of addition, which is subtraction. So 4 minus 4, and then 36 minus 4. I'm left with negative 8x equals 32. Now, I want to get rid of this negative 8. It's being attached to this x through multiplication. So I want to divide to get rid of it. Divide to get rid of it. And I'm left with x equals 32 divided by negative 8. It has to be a negative 4. So again, I'm going to encourage you guys to check this on your own. Okay? And then I'm going to give you a new problem. Okay? You're going to try out 18 equals 3 times 2x minus 6. Okay? Model it the same way as we did the problem in blue. And then we are going to move on. So, next up, we have this problem that can be done in two different ways. Now, it looks scary because we have fractions, but there's two ways we're going to do this. We're going to first work with getting a common denominator, and then we're going to work with clearing away the fractions. Okay? So, first one we're going to work on again is common denominator. Okay? So a common denominator is going to be getting the same number in both of these denominators. All right? So let's change our color. We'll do a green. I'm going to rewrite my problem. So I'm left with 3x over 4 minus x over 3 equals 10. Now, when I look at these two denominators, 4 and 3, I want to come up with a number that both 4 and 3 can go into evenly. So the first thing I do is look at my largest number. 3 cannot go into 4. So I'm going to get another multiple of 4, which is 8. 3 cannot go into 8, so I'm going to get another multiple of 4, 12. 3 does in fact go into 12, so 12 is my common denominator. So I want both of my denominators to be 12. Now, in order for this denominator 4 to be 12, I need to multiply my top, my numerator, and my denominator by 3. For this term over here, in order for this denominator to go to 12, I need to multiply my numerator and my denominator by 4. Okay? I do not need to do anything to my 10. So now I'm left with 3 times 3x, which is 9x, over 12 minus 4x over 12 equals 10. Now, when I add these two fractions together, or subtract these two fractions together, my denominator stays the same, and my numerator becomes 9x minus 4x, which is 5x, and that equals 10. Okay? Now, it's a two-step equation. I need to move this 12 to the other side. I see that it's being divided by 12, so I need to multiply by 12 to get rid of it. I'm left with then 5x equals 10 times 12, which is 120. Now, this last step, I see a 5 being multiplied to an x, so I want to divide both sides by 5. When I divide both sides by 5, I'm going to get 24. Okay? So that's one way to do this problem. The next way to do this problem, and obviously we should be getting the same answer if it's the same problem, so that's another way that we're going to be checking ourselves, is we're going to be doing this problem two different ways, is to clear away all of the fractions. All right? So the way that we're going to clear away all of the fractions is going to be to multiply everything by the common denominator. Now, we already decided that the common denominator over here was 12. So what we want to do is take our original equation and we want to multiply every single thing by 12. Every term on the left and every single term on the right. All right? Now, when we multiply everything by 12, I'm going to separate it. So we're going to have 12 over 1 times 3x over 4 minus 12 over 1 minus x over 3. And that's going to equal 10 times 12, which is 120. Okay? Now, if I multiply across, I'm going to get 12 times 3, which is 36x, over 1 times 4, which is 4, minus 12 times x, which is 12x, divided by 1 times 3, which is 3, and that's going to give me 120. Now I need to simplify these. 36 divided by 4x is going to be, 36x divided by 4 is going to be 9x, minus 12x divided by 3 gives me 4x, and that equals 120. Now, as we can see, my fractions are gone, right? This is awesome. Now I want to combine my like terms on the left-hand side. This 9x minus 4x becomes 5x, and that equals 120. Divide both sides by 5, and I get that x is, I can't write it over there, I guess. 120 divided by 5 gives me x equals 24, which again is the same answer I got over here. So there's a couple of ways that you can do this, but the key is that you need to find the common denominator and figure out which way you're going to use it. Okay? I have one more problem left for you guys. And this is going to be involving decimals. It looks harder than it actually is. Okay? So what I want to do first is look at what I have here. I have something that is in the tens, in the 10th spot. I have something in the hundredths, and I have another one in the hundredths. Okay? The key to this is that you need to find the largest amount of decimal places that you have. And in this case, it's 2, right? This term has 2 decimal places, and this term has 2 decimal places, which is the hundredths place. So in order to get rid of these decimal places, we're going to be multiplying by 100 all the way through. Okay, so I have 100 times 3.5 minus 0.02x equals 100 times 1.24. Now, whenever we multiply by 100, we move our decimal to the right 2 spaces because we have these 2 zeros. So this becomes 350, because if we move this once, it's 35, twice it's 350, minus, if I move this twice, I'm left with 2x, equals 100 times 1.24 gives me 124. Okay? Now again, I want to get this x alone, so I need to get rid of this 350. If there's nothing in front, I know that it's positive, so I need to subtract from the left, and now from the right. Oops, I don't want to x that out. So now I'm left with negative 2x equals 124 minus 350 gives me negative 226. Then I need to divide by negative 2 on both sides, divide by negative 2 on both sides, and then I'm left with a positive, because I have 2 negatives, 113. Okay? Now, I know it seems complicated. It's all about knowing what to multiply by. So I'm going to help you out with this next problem. I'm not going to do it for you, but I'm going to start you off. So this next problem in green that you're going to try on your own is 0.5x minus 2.325 equals 3.95. So this first term has 1 decimal point, second has 3 decimal points, and the third has 2 decimal points. So the largest amount is going to be 3, right? So what I need to multiply by all of our sides is 1,000. 3 zeros to match those 3 decimal points. Okay? Just as we multiplied this equation by 100, 2 zeros, because our largest had 2 decimal points. Okay? So please write down questions. Again, it's really important that you come to class asking me questions. I can always go over a problem that you didn't understand from this video, so please make sure that you're paying attention. Thanks a lot.